Hello, how are you doing, dear students? Now today we will see the calculus part of the grade 12 mathematics entrance examination in English. This is part 16. As you know, it has been a long time since I post my last video, and therefore let us begin from where we stopped in that video. Let us begin by solving this question first. Here, question number 7, it says, which one of the following is the equation of the curve passing through the point 3, 2 and having slope 2x squared minus 5 at any point x, y? That is what the question says. Here are the choices. Then to find the equation of this curve, what we have to do is the following. I have already solved it here. Let me show you here. You have two options to find the equation of this particular curve. One, simply by letting the slope which is given by the change in y over change in x as dy dx is equal to now the given slope, or by letting f prime of x with this slope, by equating f prime of x with the given slope. And now here, suppose slope of the curve is given by dy by dx is equal to 2x squared minus 5. By multiplying dx with this expression, just by this expression, we have dy is equal to 2x squared minus 5 dx. And then here, integrate both sides. If we take the indefinite integral on both sides, what we will get is the following. The integration of dy is equal to the integration of 2x squared minus 5 dx. Then the antiderivative of this one, the integral of dy, is simply y, because here the coefficient of dy is 1, and an antiderivative of 1 with respect to y is going to be y. Therefore, y is equal to, again, the antiderivative of 2x squared, it becomes 2x cubed over 3, and put minus here. The antiderivative of 5 is also 5x, because if we differentiate this one, we will get 5, and also if we differentiate this one or derivate this one, we will get 2x squared, and therefore y is equal to 2x cubed over 3 minus 5x is considered to be the antiderivative of 2x squared minus 5. Always, since any parallel curves do have the same derivative, then we need to add here a constant c, a number c. Therefore, y is going to be 2x cubed over 3 minus 5x plus c. Also, from the equation itself, from this question itself, the curve is passing through the point 3, 2, and therefore 3, 2 must satisfy this equation. It must satisfy this equation since it is on the curve. And here the first coordinate is the value of x, and the second coordinate is the value of y, and replace y by 2 and x by 3, as we can see here. In place of y, replace y by 2, and then is equal to 2 over 3. In place of x, replace x by 3, which becomes 3 cubed, minus 5 times, replace this x also by this 3, and plus the constant c, which we are going to solve or find out. And here, this implies again 3 cubed means it is 27. When 27 is divided by 3, it gives us 9. 9 multiplied by 2, which is written as such, 2 times 9, minus 5 multiplied by 3 gives us minus, which is 15, and then plus c. This one, 2 times 8, 2 times 9 becomes 18. 18 minus 15 plus c is equal to, this is the value of y, which is equal to 2. And then 18 minus, by subtracting 15 from 18, we will get 3. 3 plus c is equal to 2. This implies, since this is a linear equation, simply find c by moving this 3 to the right, which becomes minus 3, and therefore C is equal to 2 minus 3, which is minus 1. And this minus 1 is a value of C, and therefore replace the C by minus 1, which is done. Now that is going to be the equation. Replace C by minus 1, and therefore y is equal to 2 over 3 x cubed minus 5x in place of C minus 1. This is the equation of this curve. The curve which is passing through 3, 2, having slope 2x squared minus 5 is going to be this one. A, y is equal to 2 over 3 x cubed minus 5x minus 1. Okay, now let us turn to the next question. Question number 38. Question number 38 says, if g of x is equal to x times f of x minus the square root of f of x, and also f of 2 is equal to f prime of 2 is equal to 4, then which of the following is equal to g prime of 2? That is what the question says. Now to solve this one, to find g prime of 2, what we have to do is derivate g of x is equal to x f of x minus the square root of f of x on both sides of the equality, which means derivate this part and then derivate this part. Here we will get this one, g prime of x, the derivative of g of x is g prime of x, is equal to the derivative of x f of x applies the product rule of derivative. First derivate x multiplied by f of x, and then put the plus sign in between, derivate f of x multiplied by x. That is the derivative of x, x prime, multiplied by f of x plus x times, again, the derivative of f of x, it is f prime of x, minus the derivative of radical f of x, or the square root of f of x means 1 over 2 times radical f of x, and by chain rule again derivate f of x, which becomes f prime of x. And here the result will become like this one, g prime of x is equal to the derivative of x is 1 multiplied by f of x, it becomes f of x, 1 times f of x plus x f prime of x minus 1 over 2 radical f of x multiplied by here f prime of x. Since we are asked to determine or to find g prime of 2, just replace x everywhere in this equation. In this equation, replace x by 2. We will get g prime of 2 is equal to f of 2 multiplied by, plus, here in place of x, replace x by 2, 2 times f prime of 2 minus 1 over 2 radical f of 2 multiplied by, again, f prime of 2. Now, as it was given in the question, the value of f at 2 is equal to 4, and the value of f prime at 2 is also equal to 4. And therefore here, f of 2 means it is 4 plus 2 times f prime of 2 is also 4. 2 times 4, it is 8, minus f prime of 2, again it is 4, over 2 times radical f of 2, this is also 4. Since 4 is a perfect square, we can take out from the square root, it becomes 2. 2 times 2, then we have 4. 4 divided by 4 gives us 1, and also 4 plus 8 gives us 12. 12 minus 1 is equal to 11, and therefore g prime of 2 is equal to 11. That is our answer. The answer therefore is the one in choice C. In choice C, this is the answer. Okay, now let us move to the next question. Question number 39, it says, if f capital of x, f capital x is an antiderivative of f small of x is equal to 1 minus 2 over x squared, and f capital of 1 is equal to 0. Then what is f capital of 2? That is what the question asks us. What is f capital of 2? Now let us begin. It is given, what are given? F of x is equal to 1 minus 2 over x squared is given, and also f of 1 is equal to f capital of 1 is equal to 0 is also given. And another given is, we have been told here, f capital of x is an antiderivative of the small x, the small f, and therefore what is required again? F of 2. Therefore, since f capital of x is an antiderivative of f small x, we can write f capital of x is equal to the integral, the indefinite integral of f small x dx. Also, f small of x is also 1 minus 2 over x squared, and therefore just integrate this part only. Here, to integrate this one, what we have to do is change x squared here, 2 over x, rewrite 2 over x squared as minus, here, minus 2 over x the power of minus 2 as a power function, simply as a power function. This fraction, change this fraction as a, write this fraction as the power function as such, multiplied by dx here. And then the antiderivative of 1 becomes x, because when we derivate x, we will get 1, minus in between, the sign in between is minus 2, and the integral of x the power of minus 2 becomes x the power of minus 2 plus 1 over minus 2 plus 1, and plus a constant number c. And then this one becomes as follows: x minus 2 plus 1 becomes minus 1, and therefore x the power of minus 1, and also the denominator is also minus 1, because the sum of minus 2 and the 1 is minus 1. And when this minus multiplied by this minus, we will get positive, and therefore this minus changes the sign here to positive as such. X plus 2x the power of minus 1 plus c. X the power of minus 1 can also be rewritten as 1 over x, and therefore the final expression can be changed as x plus 2 over x plus c. Now it remains to find the value of c only. Once we get c, it is done. We can simply find f capital of 2. Now another thing that was given is f capital of 1 is equal to 0, and therefore now here replace or substitute 1 for x here and equate the result with 3, which means 1 plus 2 over 1 plus c must be equal to 0. This implies, since the sum of 1 and the 2 is 3, therefore c is equal to minus 3. We got the value of c in that case. Therefore f capital of x is equal to x plus 2 over x minus 3. Once we get the right function, then we can find the value of this function at x is equal to 2 as such. F of 2 is equal to, in place of x, just substitute 2 in place of x, or replace x by 2 plus 2 over again 2 minus 3. 2 divided by 2 is 1, and therefore 1 added with 2 is 3. 3 minus 3 becomes 0. Also f of 2 is 0, similar to f of 1. F of 1 here is 0, and also f of 2 is also 0. That is what was required to find. F of 2 therefore is equal to 0, and our answer is the one in choice B. In choice A. Okay, now let us proceed to the next question. The next question is about one of the application of the integral. One of the application of integral. Let us see. What is the area of the region enclosed between the graph of f of x is equal to x squared minus 4, the x-axis, and the y-axis on the interval from 0 up to 3. That is what the question says. What is given? Our function f of x is given. F of x is equal to x squared minus 4. And what is required? Area enclosed by the graph, the region bounded by the graph of the function between x is equal to 0 and x is equal to 3. Now, if we calculate the area of this function and the x-axis between 0 and 3, and if we use simply the integral as such, then it is wrong. Because, let us see, the first thing you have to do is try to draw the graph first. This function is a quadratic function. The graph of any quadratic function is either upward parabola or downward parabola. In our case, it is upward parabola since the coefficient of x squared is positive, and therefore the graph look like this one. First find the x-intercept and the y-intercept. The y-intercept is simply minus 4 and the x-intercept is 2 and the minus 2. It can be obtained as such by putting just f of x is 0, by equating f of x is 0, and then solving for x squared, we will get minus 2 and 2 as an x-intercept. And then now here, since we are asked to find the area enclosed between the graph of the function, the given function, and the x-axis and the y-axis between 0 and 3, then what we have to do is just shade this part, call it A1, and shade this part, call it A2. The area, as you can see, half part below the x-axis and the other half part is above the x-axis, which means between 0 in the interval from 0 up to 2 it is below the x-axis, and from 2 up to 3 it is above that region which is enclosed between the graph f of x and the x-axis is above the x-axis, and therefore above the x-axis it is positive. Area is always positive, we know that, and below the x-axis the function is negative value. Since it has negative value and also area is always positive, we have to multiply. In this region we have to multiply the integration, this area by minus, just like this one here. Note here, number 1, if f of x is less than or equal to 0 in the interval a up to b, then the area is always given as minus of the definite integral from a up to b f of x dx. That is the area, since the area is always positive, and therefore now the total area of the region that is enclosed in between the x-axis, the y-axis, and the function in the interval from 0 up to 3 is the total sum, the sum of the two areas, area A1 and A2. Just like as such, A total is equal to A1 plus A2, but A1 is below, since the function is, the region is below the x-axis, we have to multiply by minus here as such. From 0 up to 2, the integration here, multiply by minus, and then x squared minus 4 dx plus A2, it is simply positive, it is from 2 up to 3. From 2 up to, our interval is from 2 up to 3, and therefore evaluate the integration, the limit of integration, take the limit of the integration here 2 and 3, x squared minus 4 dx. Now this implies the integral of x squared means it is x cubed over 3 minus the integral of 4 is 4x evaluated from 0 up to 2, since our lower limit is 0, lower limit of integration, and upper limit of integration is 2. Evaluate this antiderivative of this function from 0 up to 2, added with, and again also the integral of x squared minus 4 becomes x cubed over 3 minus 4x evaluated. Our limit of integration is 2 and 3, and evaluate from 2 up to 3. And then here multiply this one by minus x cubed over 3 plus 4x. And then when 2 is replace x by 2, actually substitute x by 2 here. 2 4 times 2 means it is 8 minus again 2 cubed over 3, which is 8 over 3, minus again, put again, replace x by 0, and the result is going to be 0, plus, and here we have substitute 3 in place of x first, which is going to be 27 over 3 minus 4 times 3, and then minus replace 2 here x by 2, which is 2 cubed over 3, 8 over 3 minus 4 times 2. Then by performing this operation, we finally will get 23 over 3. The result is going to be 23 over 3. And therefore, here from this choice, B is the correct one. B is the correct one. Suppose if we proceed like this one, if we simply find the area, if we evaluate or compute the area as such, we will get one of the answer here, which is incorrect answer actually. And that is it for today. See you next time. Please, if you like, subscribe and click the like button. And also, if you have any suggestion or comment, let me know and comment below, please. Thank you. Bye bye.